we're going to graph some basic polar graphs. And I'm going to name them by cases just to kind of put them in a general form. So the basic ones are going to be case 1 through 4. They don't require much work at all. In the next videos, we're going to do the case 5, 6, and 7. So r equals 3 means that there is absolutely no theta, okay? So what that tells you is that if you were to draw a little graph here, say r theta, theta can be anything. It can be negative pi over 3, it could be 0, it could be like 5 pi over 6, and the angles could go on. It could be 7 pi over 4 and so on. But no matter what theta is, r is always 3. That means that the angle can be anything. It can go around the circle over and over and over again, and the r is always 3. So for example, r3 would be here. R equals 3 would be here. At 5 pi over 6, r would be 3. And so it would always be 3. And so when you connect all those points together, it's a circle of radius 3. That's all it is. So I'm going to do it in... Perfect. Let's make that a little thicker. There it is. So anytime, case 1, very straightforward. Anytime that you have, I'm going to make this a bit smaller, r is equal to k, where k is a real number. This is a circle where the center of the circle is at 0, 0, and the radius is the absolute value of k. So r could also be -3, but remember, when the r is negative in polar, it just means you're walking backwards. So you're still going to create a circle of radius, whatever the number is of the absolute value there, positive or negative. So that's case 1. Case 1, very straightforward, r equals, very simple equation, it's a circle. Case 2 now is that theta is there and r is not there, which means that r could be -4, r could be 2, r could be 3, and theta is always going to be 4 pi over 3. So 4 pi over 3 is the angle in quadrant 3. But remember that if the r is negative, it's going to go directly across. So 1, 2, 3, 4. Here would be -4, comma, 4 pi over 3. Then we have 2. Then we have 3. So what's happening here is that the angle is always going to be 4 pi over 3, but the r can be positive and it can be negative. So what you're going to create when you connect all those r's is you're going to create a straight line. So again, you don't need to do the table. I'm just doing the table to show where I'm getting this from. But as long as you know the case, you can just draw the line. So the case 2 is that theta is equal to k. K is any real number, which will be an angle. So it's a line through angle theta. So there it is. Case 1, case 2. Like I said, you don't need to draw the table. I'm just drawing it to show you where it comes from. Case 3 and case 4 are almost even easier, as long as you can see the equation. Case 3 is going to be the equation where you have a number is equal to r cosine theta, where k is, again, any real number. But r cosine theta in rectangular is x. So this is k equals x. So anytime you have k equals x, this is a vertical line. So you're looking at when it's -2, x is equal to -2. So you go to x is equal to -2, which is 2 to the left. And here it is. Here's our line. Let's make it a little thicker. And I'll add little arrows to it. Perfect. Now you might know what case 4 can be. So case 4 is going to be k, a number, is equal to r sine theta, where again k is any real number. And so from before, r sine theta in rectangular is y, so this is k equals y, and that's a horizontal line. And so here it's 3, so we have y equals 3. So 3 is up 3, 1, 2, 3. And here's my, ooh, that doesn't look very good. Let's try again. 1, 2, 3 is here. Okay, better. And so it's a horizontal line. So here are the basic 4 cases. Very, very straightforward. It doesn't require much work. All you need to know is to be able to recognize that what the case, like it's a circle, it's the line, it's a vertical line, it's a horizontal line, and then you can graph it with minimal amount of work. I see here that I didn't write y equals 30. Perfect. There we go.